Welcome to my presentation. My name is Ayşe Gamze Sevinç. This presentation topic is investigation on potential use of olive burning waste as a biosorbent for boron removal from geothermal water. This is my outlines. Aim of the study to obtain an environmentally friendly, cheap and efficient adsorbent by using olive burning waste to remove excess boron by adsorption under optimum conditions, to make geothermal water sources suitable as irrigation water, and to bring an innovation to literature. Boron is found in nature mostly as sodium and calcium borates and compounds called boric acid salts, sodium tetraborites, and boron oxides. And boron is element needed for the growth and development of plants and animals or humans. This affects the absorption mechanism of boron on adsorbents. Figure 3 distribution diagram of boric acid and borate ions in solution at various pH, and figure 3 equilibrium equation between boric acid and from species. Boron concentration is very important for the growth of plants. Too much or too little boron in irrigation water affect the growth of the plants. For example, in the lack of boron in irrigation water, the plant stem and root apical meristems die. As can be seen in figure 5, the lack of boron in the plants can damage the plant in all respects. For example, yellowing and florking or leaves in the figure 5. And boron toxicity, if the boron concentration is silently above the minimum limit, it will have a negative effect on the plant and show toxic properties. And boron accumulating in plant tissues poses a potential danger to the health of those who consume these foods. This part is World Health Organization, European Union, and Japanese water quality standards drinking water limits for boron. Water contamination by boron is one of the widespread environmental problems, since even a few parts per million present in irrigation water. For environmental protection, an efficient solution must be provided to reduce the boron concentration below the permissible level before being discharged in the environment. Geothermal water is an environmentally friendly renewable energy source. Boron concentrations comes to fore depending on the location of the geothermal waters. Therefore, in order to use geothermal water more efficiently, boron concentrations in geothermal water should be within appropriate limits. Using many alternative boron removal methods, for example, coagulation, adsorption, ion exchange, reverse osmosis, membrane filtration, etc., many removal methods. We choose adsorption method because adsorption method has gained great attention and is considered as one of the main innovative methods of treating many pollutants from water. However, the quest to develop efficient adsorbents with high sorption capacity for removal of micropollutants in water remains a challenge. Investigations show that the absorption of boron is affected by both the distribution of boron species as well as the type or number of active sites on the adsorbents. Other schematic diagram for the interaction between boric acid borate and composite particles. Next presentation is literature survey. In literature, using many different waste sources, for example, rice, cotton cellulose, banana frond, activated carbon, olive beverage, and eggshell, and different absorption capacity. And next, experimental study. The geothermal water from agricultural fields in Aydın and boron concentration of the geothermal water nearly 11 mg per liter, and same geothermal water pH is 7.97. This table is cation and anion analysis of the geothermal water. Olive burning waste is collected from Muğla and Ege University lands. Olive burning waste with a biochar conversion rate 25% were used as a biochar resource. Olive burning waste was first washed with distillated water to remove surface contamination, and after drying, cutting, grinding process, it will be converted into biomass by slow pyrolysis. Mainly three parts in this study. First, the preparation of olive burning waste in terms of temperature, gas flow rate, and time. Secondly, modification of olive burning waste in terms of chemical agent, concentration, and time. Lastly, application of olive burning waste for remediation of boron from geothermal water in terms of amount of biosorbent dosage, pH, temperature, and concentration. Biochar is the carbon-rich material produced from organic feedstock under certain thermal combustion in the absence of oxygen. The conversion of common waste to biochar could be an option for the environmental sustainability. Rich carbon content, large surface area, stability structure, and high cation exchange capacity are biochar advantages. And many biochar applications, for example, soil remediation, catalyze and activator, wastewater treatment, etc. Many applications. Biochar preparation methods, pyrolysis, gasification, and hydrothermal carbonization are the common methods for biochar preparation. The preparation conditions, including temperature, heating rate, and air conditions, have important influence on the physicochemical properties of biochar. Slow pyrolysis is also called carbonization and emphasizes the solid charcoal as main product instead of fast pyrolysis with emphasis the liquid product. For the modification of biochars using many agents, acids, alkaline, oxidizing agents, metal oxide, carbon materials, and steam or gas agents. And this figure characterization methods for biochar, many characterization methods using for the biochar. Using slow pyrolysis process and 20 gram oil burning waste and approximately 10 gram of biochar is obtained as a result of pyrolysis. Pressure 1 bar, flow rate 2.5 liter per hour, and pyrolysis time is 30 minutes. This figure schematic diagrams for using pyrolysis process. Section A before pyrolysis process, section B after pyrolysis, and last section after grinding biochar. Activation of biochar with metal hydroxide increases porosity and surface area. With increased surface area and porosity, more oxygenated functional groups are formed on its surface, and functional groups allow metal cations to be chemically adsorbed on biochar. For this reason, potassium hydroxide and mannitol were used to modify the prepared biochar for use in boron removal. Prior to mannitol and potassium hydroxide modification, biochar was connected with 1 gram biochar per milliliter of 1 molarity hydrochloric acid for 3 hours with stirring. In this way, the biochar, which is filtered and washed with pure water, is prevented from giving color to the washing water. Boron analysis was performed with UV visible spectrophotometer using azometine H method. Simply, boron removal efficiency has been investigated throughout equilibrium tests in terms of modification type, biochar amount, pH and temperature, kinetics test, temperature and stirring rates. Results and discussion. Effects of pyrolysis conditions. When we examined the pyrolysis conditions, better results were obtained at 400 degrees Celsius, 10 degrees Celsius per minute, pyrolysis temperature rise, and 30 minutes in the best modification conditions. It was seen that mannitol was more efficient as modifying agent, and agent molarity is more efficient result of 0.5 molar mannitol, and absorption time of 6 hours more efficient. In this graph gives information about the structure of the biosorbent we obtained. We look at the wavelength values in the graph. It can be seen polyphenol aromatic structures may be carbohydrate and carbon-oxygen double bonds may exist. It is seen that the mass loss for the modified and unmodified sample is small in temperature changes in this graph. Boron removal increases in direct proportion to the amount of biosorbent. The economic view optimum amount was chosen as 2 gram per milliliter. When the pH effect was examined, it was decided to continue the study with the original pH of the geothermal water since the boron removal results of different pHs were close to each other. Also, in this was changing the structure of geothermal water by adding chemicals, for example, hydrochloric acid, potassium hydroxide was prevented. This table is conditions of the absorption study for the concentration, three different temperatures. The data obtained from equilibrium studies have been evaluated employing the isotherm models. These isotherm models Langmuir, Frank, Riddick, Peterson, DKR and Temkin models. The results indicate that the absorption of boron fitted better the Franklin isotherm models. Kinetic tests were performed in the three negative flex temperatures and stirring rates, three different temperatures and three different stirring rates for 24 hours in the water bath. The data obtained from kinetic studies have been evaluated employing in the isotherm models, such as first order, second order, and Elovich kinetic models. The time-dependent variation on boron concentration in geothermal water at different temperatures. When the results are compared, it is seen that there are fluctuations in reaching equilibrium at 25 degrees Celsius. And when the results are compared, it is seen that there are fluctuations at all mixing speeds in reaching equilibrium. This table is results of the kinetic models. These results indicate that absorption of boron fitted better the second order models, all of the conditions. Last section is conclusion. Studies were carried out with both model solution and geothermal water. As a result of these studies, a better boron removal was obtained in absorption study with geothermal water. The pyrolysis temperature, which provides the most boron removal, was determined as 400 degrees Celsius. And after determining the optimum pyrolysis temperature, amount of temperature increases was studied and three different rise temperatures. As a result, it was concluded that the most efficient temperature, 400 degrees Celsius, and most efficient temperature increase was 1000 degrees Celsius per minute. When the modification conditions were examined with mannitol and potassium hydroxide, it was observed that mannitol provided more efficiency than potassium hydroxide, and as a result of these studies, the most efficient boron removal was obtained with biosorbent modified with 0.5 molarity for 6 hours mixing time. When the biosorbent amount was examined, it was decided to continue with 2 grams per milliliter geothermal water in terms of the cost. Since close results were obtained for pH effect, the experiments were continued to be carried out at the own pH of the geothermal water. In this way, accurate results will be obtained at low cost without causing change in the structure of geothermal water. And references section. This is my references. Lastly, this research study was financially supported by Ege University Research Foundation. Thank you for listening.